for this set of value. I need to insert all of this value in the tree. Now, first question that is I am going to ask you, where this value will be get stored? I require your answer, your interventions in each and every area. So if I need to store this set of value in a tree, what is the basic structure that we are going to follow in order to store them? Where it is going to be stored? First question to you. Whatever you knows, whatever you understand, from your understanding, you give me the answer. If you are wrong, no issues. If you are correct, it will be a good thing. My first question to you, Anurag is there. I'm going to ask each of you. Either you will answer me or I will ask you the question student by student.
Yes, I'm there, sir.
Okay, fine. So Anurag, Rishikesh, and all other students are there, and I am.
Sir, can you repeat the question?
Yeah. I am doing one thing for you. Just when a binary tree is formed, where all values are stored. What is the name of it?
Sir, in a node.
One answer I am getting node, right?
Yes.
How many of you are who has given me the answer? Please, actually, I haven't seen your name.
Shivani, sir.
Shivani is saying it is stored in node. Anybody else can help me out? Any other things I need to say, or this will be what Shivani has told is correct?
Root node or parent node?
Ultimately, node. Am I right? Yes, no.
Yes, sir.
Yes, sir.
Okay. Now, my next question to you. How a node is formed? First answer. It is a memory location? Yes, no.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
It is a memory location. Fine. So, what does that memory location will contain? If it is a memory location, I am assuming this is a memory location. So, whenever this memory location will be created, it should have a memory address. I am assuming this is the address of the memory location. Now, tell me, whenever I am supposed to create this node, what does this node contains?
The and address of
Contain data.
address of the next node.
Data and address.
So I got answer one, data.
And address.
Address.
Address of a next node.
Address. Now one answer I got, address of the next node.
Left and right.
Yes, sir.
So first of all, you need to tell me how many address location will be there. 1, 2.
2.
2, sir.
Two.
Address object. And what they are going to handle it? They are going to handle the address of the next node. Am I right?
Yes, sir.
Yes, sir.
And these nodes can be two different locations. Am I right?
Yes, sir.
Yes, sir.
Okay, fine.
Left and right.
So one is known as left address and another is known as right address. Okay. So how I can decide which node will go in the left, which node is go in the right?
Sir, by seeing the greater than less than.
How to decide?
The node which is lesser than root node.
Based on the parent node.
Go to
So
the-
in every time, I need to first identify root node. Correct?
Yes, sir.
And in context of
Greater than
root node, what you are saying, value less than
Yes, sir. Yes, greater than-
root
Yes.
should go in which side?
Left.
Left side.
Left side.
Left to right, sir.
Left to right or left? Be specific.
Left,
Left
sir.
side.
Left, sir.
If value less than root, it should go into the left address. Correct? Okay. If anyone not understanding, ask me the question then and then. This should be your way of practice. Now, second thing, if value greater than root will go, of course, only one place is left, that is in right. Okay, yes, no, any confusions? So now come back to this scenario. This is a node, correct? I am thinking it is going to be created over here, so it should have two particular positions. That means I can say there are three compartments of node. One is its left side, one is its right side, and middle one is basically central locations. You can say there I am supposed to store my data. That's it. Now come to this value. So if we are supposed to form a binary tree, and I am thinking these are the sequence of numbers that we are going to store over there. However, binary tree can be capable to store any data, whether it is number, whether it is particularly character-based data like string, name, or it could also store object, which is a heterogeneous form of data. So ultimately my data, we are assuming over here that I am going to put some set of integers, and this is the sequence of value in which I am going to put these integers. First thing, tell me where 67 will go, or what 67?
67 in the left side it will go.
So 67 is going for the very first time it is encountering with the value. That means still I don't have any node with me. So it will be treated as always as your root.
Sir, but you have written 90. What is that?
This is address I have written here.
Okay.
Okay. So this is nothing but whenever a node will be created, it occupies a memory, and every memory is having an address. Right? I am assuming anything I will write outside of the box, please try to assume it as it is the address of the node. Clear? So this is your address of the node. So for the very first time I am encountering with a value, I am getting 67. I am not at all discussing any of the code. First, we will discuss about the scenario. We try to visualize them, and then I am coming and match them with my visual effects. So over here, it is the address of the node, and 67 as because the first value, so it will be treated as what? It will be treated as your root node. So 67 will be placed over here. But does this node having any value in its left hand side or right hand side?
No. None.
Nothing. Now, I am assuming another node I am going to create, and that node will push going to put a value called 34. Right? So by looking into it, first scenario, I am going to allocate a memory. I am going to if it is a node, it should have 3 set of value. And I am going to think that 34 need to be added, but I don't know where it need to be added. So first, what is the process that I will follow? First, I will follow number 1. In this case, just think, forget about the picture, forget about the things. Whenever I thought to insert a value inside of a binary tree in the form of node, first I will check, is
Possibly compare.
this tree having a root node? Yes or no? This will be number 1 checking. Second, if it is yes, then I need to check, is the value of new node is less or greater than node? Yes or no? Tell me. First, I have to check for any type of insertion in a binary tree. The first and foremost scenario will be, first I am going to check, is the root binary tree having already a root? Either answer will come yes or no. If it is root is null, then I can say binary tree does not have any other node, so it become a root. And second probability is what? If this binary tree is already having a root node, which is containing our data, I need to check whether the value of the new node is less than of that or not. If it is less than, then what to do? You tell me. Where I need to think about
Left
my
side.
new node.
Left side.
Left side.
So we will put the address in the root node. Left side.
So now just wait. Left side when the value is less than root. Correct?
Root.
So,
Yes.
or in the same manner, it will be right side when it is greater
More
than
than root.
right?
Yes, sir.
Understood? Now, is this the only scenario that I am going to check?
Equal to is left.
No. I am just forgetting the equal to. I cannot insert duplicate over here. Okay, just forget about it. Now, in this case, whenever I am going to take a decision, once again, I need to think, okay, does my left-handed string or left pointer or my right pointer, where I am thinking to put my new node, is there already any value is available over there? Because it may happen, maybe I have already a node over here, maybe a separate value which is less than 67, or maybe there is also a probability there is a second level node is already available in your right hand side. In those cases, whenever I am doing my program, I need to first confirm all of these questions, because first I am having a root or not, number 1. If it is not, I need to create it as a root. My insertion will be happen in a form of a root. Second, if I am having a root, then I need to check where my new node to be get inserted. Either it will be in the left hand side or it will be in the right hand side. Depending upon if the new value is less than root, I need to go for a left hand side. Or if the value is greater than root, then I need to go for the right hand side. Now, once again, once I will take this decision, I can able to understand where in which side my new node will be get inserted. But it is not true. Okay, every time root will be the alone. It may possible there is another value in your left hand side, say already I am having a value in my left hand side. It is also impossible. Maybe it is containing say 45. And it has a memory address. Suppose this memory address is 98. Possibilities is there? Yes, no. Could be possibility. It could be any possibilities. Maybe the second value is the second node, second respective value of the node, possible. Maybe already I have a second node inside of my left pointer, and now I have created this new node. So in context of that, I need to think in a different way, because there is a possibility either my left node is already being engaged. In this case, my left node is already having a memory address called 98, and therefore it is being already connected. This possibility is also there. So I need to check as a programmer what are the possibilities and how I can resolve that thing. Because whenever I am thinking to add a node in a particular binary tree, first possibility, the node become a root. Second possibility, root and the node become the second most node of the list, and it could become with my left hand side or right hand side. But once again, if I am thinking it is coming in left hand side, it does not mean that my left hand side is blank. It's possible there are further any other node already been inserted. So these are the three possible solution scenario comes. So whenever I am thinking to add a node for any of the sequence, it could be second, third, fourth, fifth. Every time I have to iterate all three possibilities. If my tree is having a root node, second, if it is already having a root node, then I need to check my left pointer. It should be appeared in the left hand side or right hand side. But before taking this decision, once again I need to check, is my left hand side is blank or already having another value? Then once again I need to think where I need to put my new node. So there are three possibilities comes in front of you. So now come to this particular point, forget about I am going to be stick with this set of values. So forget about this scenario, forget about where is this particular node. It is not there. I am thinking according to the picture, right? So what I am going to do, I am just removing it. But I should know at the time of inserting this value, I must need to check whether my left hand side already having a value or not. So how I am going to check? Question arises, how I am going to check my left hand side is having a value or not, because I have already inserted 67. Now I am encountering with a value called 34. So first I am going to check my root binary tree is already having a node with me. Yes, no. So I found yes, that is there. Now I need to check if it is there, then what is the new node value? 34. So if it is less than, so I am planning, okay, this value will become in the left hand side pointer. But how I am going to check if this left hand side pointer is already having any value or not? Because if it is having a value, that means there is an existence of node. If it is not having any value, then I can say, okay, fine. Then the next node will be appear in the left hand side because its value is less than 34. Am I understandable? Are you understanding me? Yes, no.
Yes, sir.
So how I can ensure that my left hand side value is not there? Logic, think logic.
We will see if it's null or not. If it's null, then
Let me check. If my LPTR, whatever the left pointer, equal to null, answer may comes yes, no. So if it is null, then I can say there is no such kind of node in my left hand side. So then what to do? Assume this particular new node is having a memory address associated with it 98. So I found, first I will found, is my root equal to null? First question comes over here. Think, I am just technically coming with this. If root equals to null, if answer is say no, then I am going to choose what is the value. That means second level scenario comes is value of new node less or greater than root. So if I will find it is less than root, then I will check if LPTR equal to null. Then I can assure myself, yes, there is no engagement of new node over here till now. And if it is so, then what to do? I need to put this particular node over here in its left hand side. So how I can put this particular node in over here? How it is possible technically? Think, if I will pass this 98, the memory address of this node over here, then will it be go and communicate with it by passing the value 98? Think and tell me. If anyway I will pass the memory address of the new node in the left hand side of your root node, what it will do? It will now pointing to this particular memory address. It will be get connected. Yes, no. Say Dipesh,
Yes, sir.
I need to communicate Anurag. Say for example, and I don't know what is Anurag or where is Anurag. So if Dipesh knows it and I know Dipesh, then what will be the process? I can easily reach to Anurag. Yes, no.
Yes,
Just imagine I don't have number of Anurag, or I don't have any existence of Anurag, where Anurag stays. Is it in web 26, 27, 28? Forget about it. But Dipesh knows that. And I know Dipesh. So what I will go? In order to communicate to Anurag, I will go to Dipesh. Root. Previously it is does not know who are the other nodes over here. Now root will get the address of a particular node, any of its address position. So what will happen? I have a direct connection with that particular memory. I can jump over there. So this is the process. Now think the next value comes. So just forget about this value. Think about a value. I am after 34, I am going to insert a value. Suppose 20, 30. Third value it is. Forget about my list. And it is third value. Once again, my algorithm start from the beginning. Do I have a root? Yes, I have a root. If it is there, compare the value of root with your new node. What is your new node? Your new node will be get created with another set of value. Possibly that value is over here according to my third value. It is basically 30. So now I need to decide. I have a root which is called 67. So I will compare the value with 30 with 67. What result I will found? 30 is less than 67. So I prepared myself, okay, this is a new node. I need to insert it over here. So I need to insert it over here. That means it should be appear to the left hand side of the root. Yes, no? Yes, it will appear into the left hand side. Then I have to check, is my left hand side address value is fulfilled already? Yes, no. How? If LPTR is null. Then say, I got answer. No, LPTR is already having a value called 98 or it is not null. So I cannot put it over here. Then where to jump? I need to jump in this location. In this particular node. Because why I need to jump in this location? Because I have found it is not null. That means I cannot directly push this value over here because it is already occupied by another node. So I need to at that time, but I need to put it in its left hand side. So I need to go and continue with my node, with the next node in the
Sir.
sequence. Yeah,
I have a question.
yeah.
Sir, as you wrote here, if root is equal to null, then again we are like when we are putting 34, like here in the at first memory location, there was 67 over here. So we decided that we will go left, right? Because we have 34.
But before going into the left, first the scenario comes, if my left pointer is having any value.
Yes, sir, that I understood. Then again, sir, when we are using this 34, so will we do the recursive type, or you said that again we will check we should go right or left?
See, for example, over here, first we need to understand what is my next value, 34.
Yes,
So
sir.
from here, I am first going to check root is null. No, root is not null. It is dead. Then it is greater than root or less than root. If it is less than root, then I will decide, okay, fine. I will go into the left hand side of the root. So first I will check what is the left pointer is having in my root. Is it having any value? Yes, no. If it is null or not null. If it is null, then I can take a decision left hand side pointer is blank. So I can push it over here. But if I found left hand side pointer is not null, then I cannot push it over here. It is already been occupied. So I need to jump by following that address in the another node in the left hand side. I will find 34 is available over here. Now once again I need to check what is the value of my new node. If it is 30, is it less than 34 or greater than 34? Because this will be at that time acting as a parent node of my new node. First thing, this will be at that time going to be decided whether the new node, who will be the parent of the new node. So parent of the new node, I cannot make it 67 as a parent because it is already occupied by one person, one value. So I will come back to that value. I will once again go and recheck what is the value of the current node where I am at present. I need to traverse it. Once I will traverse it, I will get a new value over here, 34. My new value need to be added over 30. So then I want to check, okay, it is less than 34. That means I need to take a decision. Okay, I need to go in its left hand side. But once again, same process will check. Is my left hand side is having a null? because then only I can put this particular memory address in its left hand side. Other than if it is occupied, then I can't. Then I need to go more one step down. So over here, imagine this is 30. So in that case, I will find key it is 34 is greater than 30. So new node 30 will be added into its left hand side. So if new node 30 will be get added into left hand side, then I need to check what is the memory address of the particular new node. If the memory address of the particular new node assume 56, then what to do? This 56 memory address has to be added over here if it is null. So in that case, I am going to add this 56 over here. And automatically what will happen? This memory address will be copied by this left pointer. So automatically I can say key this is going to be create something like this, and it will become over here, and there will be a link will be get created over here. Now once again, whenever a new link will be get added, once again there left and right. At present, what is the value of left of the new node? Tell me.
It's null, sir.
It's null because I don't have any other nodes. Neither it is having in its left null, and left or right both are having null. Now think about the next slot. This is my third value. I have said fourth value comes with 45. If it is 45, first I am going to check. I am having a root. Yes. What is the value of root? 67. So it is less than 67. Yes. Then I need to put it in my left hand side. Yes. Is my left hand side is already occupied? Yes, it is occupied. Then I need to jump to that particular left hand other left child. If this left child is, what is the value? 34. What is my new value? 45. Is it greater than or less than 34? It is greater than 34.
Greater.
So if it is greater than 34, the new node will be added in this location. Why? Always every node has two left and right. Right will be greater, left will be smaller. And this will be get continued in this section. So new node will be get added over here because it will continuously find, is it null? Yes, it is null. So just put the address, swap the address over here. So if the address value will be of the new node will be given to it, automatically this will be get done. Now, this process we have implemented in terms of program. So how this process has been implemented in terms of program? So in order to create a node, I must have a node class. In order to operate on the binary tree, I may have some setup method. So every insertion of a node in a binary tree basically deals with two sort of things. One, creation of the new node. Second, position of the new node within that binary tree by traversing it, by step, go thoroughly with it, and visit each and every address node either in the left hand side or in the right hand side, depending upon its value. And continuously start searching where I can insert the value. So now I am coming with this set of code. And I will put this picture in front of me so that both the thing I can discuss properly. So first scenario comes in my picture कि I am going to handle this particular scenario. This is the code Sangeeta has given to you. So first we are creating a blueprint of my node, what my node will handle, what my node will have. It is having one attribute called roll number, and it is having two set of node object called left and right who are going to accept your addresses. Now B node, it is the particular constructor which is taking a value. When this value will be given to it, it will put the value inside of the roll number variable. And this value of left and right will be always will be null. So whenever any node will be inserted anywhere within this position, they are having a value and they are having a left and right, both are null. That we are deciding with this code. So anybody, if whenever I am going to create something like this, object of BT node, this is the class name. Suppose B1 is equal to new BT node, and I am passing 10 over here. What it will do? It will call this constructor. 10 will be passes as a value over here in the roll number, and it will keep that value in its roll number attribute, and it will create a left and right pointer associate with it as a null. So from here I can say कि whenever I am supposed to create a new node, I need to pass a value for it, and the value will be stored over here. Whatever may be the value, I don't know, still I don't know the logic. Maybe it is 56, maybe at a 91. So value will be assigned into the roll number variable this way. And these two portions of the linked list of the node will containing a null, nothing more than that. So are you understood this set of line over here?
Yes, sir.
Yes, sir.
Any issues? Anybody? Later on, I don't want to see. Sir, once again, please redefine. Do it now. Clear it now. Right? Now, going ahead. So next line that I am coming over here, that is, there is a class, and this is the name of the class is BT underscore demo1. What is the purpose of this class? This class is going to handle all of the operation related to your binary tree. That means it should go with the initial value insertion, deletion, traversing. These three are the most common value for every binary tree. Either we need to insert a value over there, or whatever the value I have inserted, I will go and check each of them, or I will delete any of the insertion node which is already there. So these are the several operations that is going to be handled by this particular class. So this class actually going to form your binary tree. That means this class is going to create a node started from the beginning. So therefore, at the beginning, I am creating over here a particular object called root, which is an object of the B node class. And preliminary, I am explicitly putting null. Why? Because whenever this particular method will be called, this object will be created for the very first time, there will be no more any sort of node will be available over there. Now come to the next part. Next part saying, okay, this is a method, simple method, which is returning a void type. The name of the method is roll number. So whenever this roll number will be passed over here, how? I am going to create an object of this class. and I am going to call this function over there, and I will pass a value to it. I don't know where this value will be get put, how this value will be put. Ultimately, it will call this insert method. So maybe if I am passing 56 for the very first time, it is coming into this roll number variable. Now this roll number variable further will be assigned to whom? Root. How? Root is a what class object? Root is a BT node object. That means it is forming a new node for me. And if it is forming a new node for me, the value which I will pass over here as 56 will be pushed over here. And it will create two particular address pointer for you, left and right, which will be nothing but a null at the beginning, according to this. So I will pass roll number over here. In order, I will pass root element over here. But whom, where, how? I will call another function because I don't know where this node will be get added. I have only definition. Here I have created a new node with me, which is consisting of value. So if for the very first time, whenever value will be added, it will be become a root node for you. So therefore, I will initializing this root variable, which is preliminary given as a null, and I will given this duty to a particular function. The name of the function is search parent. And the search parent is actually returning you a node. Why this search parent is returning you a node? Because every time I need to find out within my binary tree, whatever the new node will be get added over here, who will be its parent? By traversing the entire node. So maybe it is 56, then it will become in the left hand side. Then once again, that same process will continue by the search parent actually. Key is my parent node at present where I am having a blank value or null value. If it is yes, then automatically it will be get added. But it will be not. Then I will go and jump into the next node. Then I will check whether this particular area is null or not. If it is not null, then once again I need to jump either left hand side or right hand side depending upon this value. So if it is 56, I need to insert. Once again, I am reiterating. It is greater than 34. So I need to check whether I am having a right hand side or not. If it is a blank, then I will add it over there. So that is the actual process. And who is going to do this process? This process is going to do by a function. It is actually locating your parent by taking two set of values. So one is roll number, one is your root. Preliminary, your root is null. So now it is passing the null value to the search parent. So it is taking roll number 56 and a node of the object as parent. So first I am creating a new node over here. And this new node is containing a null value. If my parent equal to null, so new node equal to new BT node, pass this value. So a node will be get created. If a node will be get created, who will take care of it? The parent will take care of it. How parent will be determined? The current node itself is the parent of all of the nodes because my parent is null. Who is getting the parent? Parent is actually the first node. So this is basically get done over here. So for the very first time, whenever we are adding 56, insert function will be called. Roll number will push this value or carry this value as a 56. Then it will call the search node. Search node will take this value roll number and a value called root. Already I know my root is null. So first time null value will be passed over there. So this value will be received by parent. So parent is actually having a what value over here at this moment? There is no other value. So parent is having a value called null. And what is this roll number will hold? This roll number will hold 56. Correct? Now what it is doing? It is creating a new node for me. So if it is a new node for me, will be get created. So I will just create a new node over here. A new memory will be get allotted. And new memory will be get allotted. It has 2-3 chambers inside of it. And further what I am doing, I am checking what is the value of parent. Is my parent is equal to null? Yes, it is null, because further I have created whenever I call this function at that time parent value was null. So I will pass this value over there. So if I will pass this value over there, it will containing now 56. And according to this definition, I am creating BT node object. So it will create left and right with my null. And now I am saying parent equal to new node. So whatever the address of the new node is given to the parent. So this is actually happening over here. So in this case, my new node become a parent. So it is true over here. Finally, what I am doing? I am returning that parent. So this value will be get returned to whom? Root. Now your root is having the address of the new node. So it become a root. So in this way, the first value will be inserted. Now come to the next operation. It is talking about 78. Once again, which function it is calling? Insert function is calling. What is my current scenario of the program? I am having a root with 56. So my root is not at all null at present. Now what I need to do? I need to go for a insert method. So insert method will receive this value. What value it will receive? It will receive 78. If it is received 78, what I am passing? I am calling another function called search parent. So what search parent will take as a parameter? The roll number. So what is the value of roll number over here? Tell me. 78.
78.
And now what is the value of root? Is my root is having null now?
No,
56.
sir. 56.
So I am assuming this root was created in a previously already 56 have been inserted, so it become root. So it has its own memory address, correct? If it has its own memory address, I am just assuming the memory address it is having is 100. Just assume. So 56 is the value, 100 is its memory address. So it is actually containing now what? It is now containing a value, roll number as 78 and address value is 100. Okay. So search parent will be appeared over here. So now this 78 will be received by this roll number variable. And this address, root address is actually holded by which address? Parent.
Parent.
Now, I am creating a new object. Just one sec. One sec. Just I am coming back. Just give me 5 minutes. So, actually now my search parent method will be called. I am having parent as not null. What value I am having over here? Think. It is having 100. Good. And what roll number it is having? 78. Now what it is doing? First it is checking. It is creating a null object. No issues. Now it is checking. Parent is equal to null. What do you think? It is yes or no?
No.
Which one is correct?
No.
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 If it is no, then it should not do this. It will come to the else node. Correct? Yes, no.
Yes, sir.
Now what it is checking? is parent dot roll number greater than roll number? Step come to your this. Okay, every time whenever I am going to insert a value and already I am having a root node. So first I need to take a decision whether the value of root node is greater than or less than of the newly inserted value. Depending upon that, I need to search my exact location. Am I right?
Yes,
So
sir.
over here, that location is being checked over here. Is the parent dot roll number, that means your root node dot roll number, that is 56, is less than roll number? Yes, no. It is? Yes, no. According to this value, parent is having 100, roll number is 78, root is having 56. So what is the outcome of this particular statement? It was not true. Is it true? Or is it true? Whatever is true. You tell me. Is it or is it? Parent dot roll number is greater than the roll number because we are trying to insert 78. Parent is having 56. So this level of block will be get executed. That's what I am doing. I am saying parent dot left. Once again, you are calling this search parent. You can say this is one of the portion of recursive. Actually, I am calling because why? I need to check is this value is empty or not. How I can check? I will once again call the search parent. Who is my search parent? This is a recursion function. See. Yeah. Parent dot roll number is having 56. And what value you have given in your search parent method? A roll number value that is having. So first one is true, not. Second one I am talking about is parent dot roll number. Parent dot roll number is having a value 78. Is it great? Parent dot roll number, sorry. What is the roll number? 78. This is normal roll number. I am talking about parent dot roll number. That is your root node roll number. What is the root node roll number? 56, which was I have added in the very first time. So parent equals to null? No. Parent dot roll number. Parent means this one, the root node. Parent means over here is the root node whose memory address is 100. I have given it as a comment. See. So it is now greater than. So parent dot roll number is greater than roll number? No, sorry,
No.
you are correct. It is not greater than roll number. Then what to do? I need to go for this one. Parent dot roll number is less than roll number. Parent dot roll number is 56 and I have assigned 78. So parent dot roll number is less than 78. So where I should go? I will go into my right hand side. I will call the next search parent method with the same value roll number. That means 78 will be passed once again over here to call the search parent itself. Now parent dot write. What is parent dot write? Parent is nothing but your root node. What does this root node is holding in its right pointer? Think. It is your root node, na? I have passed parent over here. From here, I will call insert number 1. Insert will take my 78 value. Then first time it will call search parent with roll number and what is the address of my root. So address of my root is going to a particular variable called parent. The address of root is 100. It is having a left pointer and right pointer. Now once again over here I am saying go and call the search parent function once again recursively. So pass the same value roll number and now you are passing not parent address, rather than you are passing parent dot write address. So what write address is holding at present? Null,
Null.
right? So null will be appear over here. So address has now become, it is roll number will be 78, but now such parent once again call itself with a new value, that is something called null. And you agree with it? And if it is null, then what to do? If parent is null, answer is yes, because it is the parent variable where you are passing the new address, that is null. So if it is null, then create a new node. Fine, I am going to create a new node. So let me see what is the outcome. So if I am going to create a new node, it will somewhere will create it with a value, it will going to create. So it should have 3 set of compartment, 1, 2. Now what I am passing over here? New node equal to new view node with a roll number. That means I am passing 78 over here. And left and right become null. Fine. Now I am saying parent equal to new node. So what is my parent? Parent is this equal to new node. So it will be created in a memory address. So assume this memory address is what? Assume this memory address is 500 or 50. So 50 will be added over here. I am passing the value to my parent. Parent will ultimately get returned to whom? As a root. So root will be actually having this value of what? Having a value called 50. So memory address 50 will be get added where? Inside of this. In this area, parent.next. So it is containing 50. Once it is containing 50, it will create a communication with this. Now what is my third value is talking about? Now this is the thing that Sangeeta wants from you. You analyze the code. Is it too tough? What you are thinking? If you are knowing, you people are knowing already what is node. You people are knowing what is address. You people knowing how to call function, how to pass parameter. Only that thing I am discussing over here. And you know how to pass addresses from one node to another. So parent equal to new node means what? Passing the address of new node to by parent. Keep faith on yourself. You can do anything. Dipesh. Dear Dipesh.
Yes, sir.
Dear,
Understood now.
is it clear?
Yes, sir.
Rishikesh.
Yes, sir. Clear.
What about Anurag?
Sir, clear, sir.
So please, this is the analysis. Dekho, everybody, we need to do some effort, take some effort. Think positively, you can do anything. You have that ability. Nobody over here, neither you or me are Einstein. So we don't have any extraordinary power in our brain. So we are going with what? Going with this kind of analysis. Only once we will analyze ourselves, you will understand gradually. That is the thing. I have shown you the process. Is it clear, everybody? If still you have any problem, I can explain it. One more step. Anybody other than these 3 people name I have given, I want to say from all of you, yes, no, at least raise your hand. I need to know all this code are understood by you. Everybody I am asking to raise your hand. Yes, dear.
Sir, please give 10 minutes. We will check I will see the code. Then
Yeah. I will give you that time. Don't worry. But till now, whatever the thing I have discussed, did you follow that thing properly? Yes, no. That is my question.
Yes, sir. Like till that point was going on, like the theory part was good.
Now,
Implementation
can
is
you
like when I
able
see
to
the
analyze?
code.
Can you able to analyze in the same manner how I am drawing the things, passing the value?
Yes, sir. Yes, sir. Trying to do that.
What I want, you need to check after this scenario, this 78, next value will be 48. That you need to analyze with this picture. You have this picture already with you. Their memory addresses are given. I need to check for the third one because third one is supposed to be get pushed over here. If you remember. So this is the thing I required. So don't worry. Even if I am telling you, by tomorrow I will go once again, maybe Sangeeta will go once again to ask you the questions for each of the lines. And you give them. We will go with this question answering sessions. So make yourself, ourselves up. Nothing more than that. Even if you people, you will ask me, okay, sir, what you have done whenever first time you have learned about binary tree, I was just crying. I know the complexity. I can understand. But how can I come out from this? I need to have a solution with me. And this is the way by which I will draw myself and I will analyze the code. And that is the only one way.